NASA just crashed a spacecraft into an asteroid, but on purpose. DART, or Double Asteroid Redirection System, was a spacecraft that was launched on the 24th of November 2021. Launched by a SpaceX rocket, most of its voyage was under the guidance of NASA's flight directors. Its destination? An asteroid called Dimorphos, about 170 meters in diameter, orbiting the parent asteroid Didymus, which is about 5 times larger. A pair of asteroids' names mean the same thing, from the Greek root of twin. The asteroids are about 9.6 million kilometers away, but pose no risk to Earth. The orbit of the asteroids ranges from just outside Earth's orbit to a bit beyond that of Mars, taking about 2.11 Earth years to complete the trip. The aim was to nudge Dimorphos off course through kinetic impact. The dual asteroid system is ideal for observing and recording the results of the impact. The asteroids are close enough to Earth that the ground telescopes would be able to record and observe what occurred. Now, close is relative here, as the asteroids are actually about 11 million kilometers away, almost 30 times the distance of the Moon. After almost a year in space, the final maneuver aligned DART with its target on the 25th of September. About 4 hours before impact, DART entered the terminal phase. The onboard Didymus Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO, was then locked onto the Didymus asteroid and looked for its moon, Dimorphos. During this phase, flight controllers stopped issuing ground command. Now, to get better images of the crash, it released the LISA Cube, or Light Italian CubeSat, for imaging asteroids several weeks ago, which recorded the final moments of the impact. Ground and space telescopes also witnessed and recorded the collision, including the recently launched James Webb Space Telescope. 50 minutes before impact, the spacecraft shifted its target to the smaller moonlet. 20 minutes left, NASA's precision lock system engaged. This means that the spacecraft completely ignored Didymus and locked its heading onto Dimorphos. With just a few minutes left, DART cut off its hydrazine thrusters, crashed into Dimorphos with a speed of 23,000 kilometers per hour. Once the impact occurred, the DRACO camera feed completely cut out. The impact launched ejector into the air, which was clearly seen by the LISA Cube spacecraft. Just minutes after DART hit Dimorphos, the LISA Cube spacecraft flew by the impact site. Photos were snapped of the ejector plume created by the impact and were sent back to Earth. The DART test mission sought to answer the question of whether it was possible to shove an asteroid off its trajectory in the case of an Earth-threatening impact using a specially designed satellite. The results and data from the collision are still coming in, but NASA Ground Control has confirmed that the DART impact vehicle has successfully intercepted the asteroid. NASA Administrator Bill Nelson states that this has been a successful completion of the first part of the world's first planetary defense test. The $330 million mission has been 7 years in development and is the first attempt of humans to alter the trajectory of an asteroid. The goal of this mission was to observe whether it is even possible to knock an asteroid off its trajectory. The target asteroid is tiny compared to the cataclysmic Chicxulub asteroid, which struck Earth 66 million years ago. That asteroid was 10 kilometers in diameter. It was this very same asteroid which wiped out 3/4 of the world's plants and animals, including the dinosaurs. Smaller asteroids are far more common and present a much greater theoretical concern in the near term, making the target asteroids suitable test subjects, according to NASA's scientists and planetary defense experts. A Dimorphos-sized asteroid could easily level a city if a direct hit should occur. The hope is that after the collision, Dimorphos will have its trajectory altered to be closer to its parent asteroid. The DART team stated that it expects to shorten the orbital path of the asteroid by approximately 10 minutes, but would consider at least 73 seconds a success, as it would be enough to prove the exercise as a viable technique to deflect an asteroid in the future. Once identified, a nudge to an asteroid millions of kilometers away would be sufficient to safely reroute it. Earlier calculations of the starting location and orbital period of Dimorphos were made during a 6-day observation period in July, and will be compared to the post-impact measurements made in October. The NASA team is still working hard to evaluate the viability of such a method of asteroid deflection, and while the results are still being observed, the calculations have been promising. And this might just be the first of what is to come in the future. If you want to watch either the launch or the impact of the DART mission, there will be links in the description to those videos. If you enjoy educational and scientific content on topics such as this, be sure to show your support by subscribing to the channel.